case you need a very quick refresher, I'm going to show you prime and composite numbers. So a prime number is any number that has only two factors, and those factors are going to be 1 and itself. So an example of a prime number would be 5, because the only two numbers that can go into 5 are 1 and 5, so just 1 in itself. 7 is another prime number, because the only two numbers that can go into 7, its only factors are 1 and itself, which is 7. So that is what a prime number is. Every other number that's not prime is then called a composite number. And composite numbers have more than have more than two factors. For example, the number 6 will have the factors 1, 2, 3, and 6. So it'll have more than just two factors. And just as a little side note, the number 1 is not a prime number. It's not a prime number because what are the factors of 1? They're only 1. It's only got one factor. And remember, a prime number has two factors. So 1 is not a prime number. Okay, so now that we've done a very quick revision, let's go ahead and answer our question. Okay, so we want to take 24 and we want to break it down into its factors, but we don't want just any factors. We want prime factors. And the good thing about this is that there is more than one way to get there, and that no matter which way you choose, you are always going to get to the same answer. So the number 24, what we're going to do now is we're going to create what's called a factor tree. And a factor tree just always has two branches. At every stage, you've always got two branches. So 24, what you are looking for now is any two numbers that multiplied give us 24. So you could say 12 times 2. Okay, so 2 is a prime number, so that ends there. That branch will not get divided any further. But 12 is a composite number. We can divide it further. So we do our two branches. And we say, what two numbers multiplied together give us 12? Now, there's more than one option. We can either say 2 times 6, or we can say 3 times 4. And it doesn't matter which option you choose, you're always going to get to the same answer at the end. So I'm going to go with 2 times 6. So I look at my numbers, and 2 is a prime number, so that branch ends there. But 6 is a composite number. I can break it down further, and so I do that with my two branches. So what two numbers multiplied by each other give me 6? Well, 2 times 3. So 2 is a prime number, that ends there, and 3 is a prime number, so that ends there. So now I need to go back and answer my question. My question, let's just get rid of this. So my question has asked me to express 24 in prime factor form. But all I've done here is I've created a factor tree. I need to answer my question. So to answer my question, I have to say that 24 expressed in, or you could do this as an equal sign, expressed in prime factor form is, and now I need to collect all of my factors. So I can see that I've got 2 showing up. How many times? 1, 2, 3. So 2 multiplied by itself 3 times is 2 to the power of 3. So that is what I put there. Okay. So now I've collected my 2's, but I've also got a 3 here, so I need to now collect that. So times 3. I've only got 1, so I don't need to put it as a power, and that is now my answer. So 24 expressed in prime factor form looks like this. It looks like 2 to the power of 3 times 3. That is the answer. The factor tree is just how you got there. So please remember that. Now, just to show you that it actually makes no difference which numbers you use, instead of using 12 and 2, I'm going to use different numbers. I'm going to use 8 times 3. So 8 times 3 is 24. And I'm going to show you how it's going to end up exactly the same. Okay, so 3 is a prime number, so that branch ends there. But 8 is not a prime number, it's composite, so I can break it down further. So I'll put my 2 branches. What 2 numbers multiplied together give me 8? So I'm going to say 4 times 2. So 2 is a prime number, so that branch ends there. 4 can be broken down further, so I do my 2 branches. What 2 numbers multiplied together make 4? I'm going to say 2 times 2, and 2 is a prime number. So I'm going to go now and collect all my 2's. And how many 2's have I got? 1, 2, 3. So 2 to the power of 3. And then I've got 1, 3, so times 3. And as you can see, the answers are identical. 2 cubed times 3. So it makes no difference which numbers you choose. You are ultimately always going to come out with the same answer. Okay. So we're going to clear the page and let's move to example number 2. And we've been asked to express 60 in prime factor form. And how are we going to do that? We're going to do that using a factor tree. So remember, the factor tree is not your answer. The factor tree is how you're going to get to your answer, but you still need to answer the question at the end. Okay, so 60. Let's break it down, and I'm going to show you 3 ways and how it works out exactly the same. Okay, so 2 numbers that make 60. Well, I could just say 10 times 6. So that becomes 5 times 2. That's a prime number, and that's a prime number. And that becomes 3 times 2. Prime number, prime number. So now that's the end. So to answer the question, I collect all of my primes of like my 2. So I've got 2 of them. So it's 2 to the power of 2, because I've got 2 of them. And then I've got a 3. I've only got 1. And I've only got 1 5. And that is how you express 60 in its prime factor form. Okay, can you see that 60 is being shown in terms of all of its prime factors? Now I'm going to show you what happens if you choose, instead of saying 10 times 6, you want to say 15 times 4. Okay, so 4 breaks down into 2 times 2, and 2 is a prime number, so that ends there. 15 can break down into 3 times 5, and they're both prime numbers, so it ends there. And if we collect all of our like primes, so 2 and 2, so I've got 2 of those, so that becomes 2 to the power of 2 times 3, I've only got 1 of those, times 5. Okay, it is identical 2 squared times 3 times 5. And I'm going to show you the last one. What if you wanted to say 20 times 3? Okay, well 3 is a prime number, so it ends there. 20 can be broken down into 5 times 4. 5 is a prime number, so that ends there. 4 can be broken down into 2 times 2, both of which are prime numbers. So again, I'm going to collect my primes. I'm starting with my lowest one, which is 2, and I've got 2 of them. So 2 squared times 3, which I've only got once, and 5, which I've only got once. And the answer comes out identical no matter which numbers you use, because it's going to break it right down until it's prime factors which can no longer be broken down any further. So you can just go ahead and use any numbers you want, and you can be confident that it's going to give you the correct answer. Alright, now we're going to move on to question 3. So now we're being asked to express 90 in its prime factor form. Okay, so by now hopefully you're getting the hang of it. We know that we want to end up with an answer that looks like this, and then we've got a whole lot of primes being multiplied. Okay, how are we going to get to our answer? By doing a factor tree. So again, the factor tree is not the answer. The factor tree is how we get to the answer. Okay, so we're going to start with 90. So I don't know, you could go 9 times 10, or you could go 45 times 2. I'll go 9 times 10. Okay, 9 can be broken down further because it's not a prime number. So what times what makes 9? Yep, 3 times 3. Now 3 is a prime number, so those branches end there. Now what about 10? 2 times 5 makes 10, and 2 is a prime number, and 5 is a prime number. So to answer my question, I'm going to start with my lowest, my smallest prime, which is 2. So 90 expressed in prime factor form is 2 times. Then I'm going to move on to my next one, and I've got 3, and I've got it twice, once here and once there. So any number multiplied by itself twice is that number squared. So then I'm going to write 3 squared, and then the last one that I've got, let's make it green. 72 in its prime factor form. Okay, so we're going to take the number 72 and we're going to say what two numbers multiplied together can give us 72. I'm just going to go with 8 times 9, so if you know your times tables, then 8 times 9 is 72. Okay, well, what two numbers make 8? I'm going to say 4 times 2, but 2 is a prime number, so that ends there. 4 can be broken down even further into 2 times 2, which is again a prime number, so those branches end there. And then 9 can be broken down into 3 times 3, and those are also prime numbers, so that ends there. So, have I answered my question? Well, no, because my question has asked me to express 72 in its prime factor form. All I've done is a factor tree. I've created a factor tree, but now I want to collect all of my factors and express 72 in prime factor form. Okay, so I'm going to write 72 here, and let's start collecting my prime factors. So I'm going to start with the lowest one, which is 2. I've got 1 here, another one here, that's 2, and another one here, that's 3. Okay, so I've got 3 of them, so remember, 2 times 2 times 2 equals 2 cubed. So that is the first one. And then I want to collect my next prime factor, which is 3, and I've got 1 here and 1 there, so I've got 2 of them. So 3 times 3 is actually 3 squared. So I'm going to put that here, and that is now my answer. Okay, so 72 expressed in its prime factor form is 2 cubed times 3 squared. Awesome. Okay, let's get on to the last example. Question 5. Okay, so we want to take the number 105 and express it in its prime factor form. Okay, so two numbers that multiplied together give us 105. So I'm going to go with 5 and 21. And if you weren't sure about this, you can go off to the side. 5 times 1 is 5, 5 times 2 is 10, 105. Okay, so 5 is a prime number, so this branch ends here. 21 is not, it's a composite number, so let's break it down. 7 and 3, and they are both prime numbers, so it ends there. Therefore, 105 expressed in its prime factor form is going to be 3. I've only got 1, so it's just 3 times 5. Okay, and I've only got 1, so just times 5. And then I've got a 7. And that is what that looks like. Okay guys, so hopefully